So welcome to the video. So today we will be trying to solve this particular question. The question code is 1721A, right? The question says that we are given an image of 4 pixels, right? So each pixel can have a very different color. Each color is defined by one of the 26 Latin letters. Okay, all of them will be lowercase itself, right? So what we are supposed to do is we want to make all the 4 colors to be the same, right? So in each move, what we can do is we can choose any number of pixels with the same color, and then we can paint them together into a different color, right? But we'll have to pick only the pixels of the same color, and we can paint them all into a different color of the same different color, right? So if we pick 2 cells of color A, we can paint both the cells into a different color. We can choose B or C or D or anything, but we'll have to paint both the pixels with that same color only, right? So in that way, we'll have to determine the number of moves that you will require to make all the pixels into a same color, right? So the input will be given in this particular format. Will be given the number of test cases that we will follow, and each test case will have 2 lines. First line will have 2 characters representing the 2 pixels in the above row. Similarly, the second line will have 2 characters representing the pixels, right? Color of the pixels, right? So we'll have to output the number of steps that we will require to paint all the pixels, to make all the pixels into the same color, right? So in this case, let me just take an example. Right? So let me take some examples, right? We can have all the colors to be different, A, B, C, D. Taking some example, we can have 2 colors to be the same, A and C and D. We can have 3 colors to be the same, A and D. Or we can have all the colors to be same at the beginning itself, right? So in this case, all are same, so number of steps will be 0. Here there are 2 groups, we will only have to select this particular color and just paint it as A, so 1 step will be required. In this particular case, we'll have to select this one once and this one once, right? And paint this as A and paint this as 2, see, A, so the number of steps will be 2. And this, since all of them are different, we can choose B first and paint it as A, then C, paint it as A, D, paint it as A. So number of steps will be 3. As some of you might have observed, the number of steps that will be requiring is the number of unique groups minus 1, right? Here the number of unique groups are 4, right? 4 minus 1 will be the number of steps we will be requiring to make all the pixels up to the same color, right? Here the number of unique groups is 3, so number of steps will be 2. Here the number of unique groups is 2, so the number of steps required will be 1. And here the number of unique groups will be 1, hence the number of steps required will be 0, right? So let us try to the logic part. So for each instance, we'll do this following. Read the input strings, okay, and find the number of unique colors present, return this minus 1, right? So I'll try to write the code for the same. So this is some boilerplate. Okay. What we'll do for character, each character in this input string. Okay, we'll just append that into the list. Similarly for this also, character in this input string 2, and append that into the list. At the end we'll print length list or set of all characters. So basically what I am doing here is we can learn this peel by peel, right? First we take this list, right? We'll make this as a set. By making it a set, we are just removing all the duplicates, so we'll have all the unique values, right? This will be a set, and then we'll convert this to a list to get the length of the same. We convert this into a list and then calculate the length of that particular list. At this point we'll have the number of unique colors present in the current configuration. Okay, so we'll just have to output a number less than 1 of this particular variable, right? So -1 I'm doing here. So let me just run the code. Right, 1 2 0 3 and 1. Right, if I can just comment this out. Right, this seems fine. Let me just submit the code. So this is accepted. So I'm just showing the code again for your reference. So for each instance we just store these two strings, and for each character in that string we just append them into a list, and then find out the unique number of unique colors already present in the current configuration, and we'll just output one integer less than that number, which will be the number of minimum number of steps that we will be requiring for this for coloring all the pixels into the same color, right? As you can see, this part is boilerplate, just reading the inputs, just iterating each string, just getting each character of the string into a list. Same thing for the second string, and this is a calculation for the minimum number of steps, right? Cool. So as you can see, all the test cases are passed here. Okay. So I have one little update. I'll be trying to solve. So this particular question is 171A, 1721A, right? So in the next video, I'll be trying to solve the 1721B question, right? This will be kind of a continuation. So the B will be at a little more difficult level than the A questions. So I'll try and solve the question and provide a solution for that B question in the same competition, right? So yeah, I think this is a question. I can just share the question with you guys. So the question says that we'll have to we are given a grid, and we just have to move from top left to the bottom right corner, and there is a laser that sits in between, and there is a origin defined for that laser, right? Origin as in the boundary defined for that laser until n number of steps, till which distance the laser will be effective, right? What we want to find out is would we be able to move from top left to the bottom right without stepping into the area affected by the laser. Right, I'll try to solve this question in the next video. So I hope you guys like this current video. Thank you, and let us meet in the next video. Bye.